Okay, this recording might take a while, but I'm actually really proud of this. But before I get started, what really threw me off was the way I drew my graph to begin with, because I kept thinking that if this edge connects this edge, I should remove this, but it wasn't visually it wasn't making sense for me until I did it this way, which is I watched some of the video presentation, and Morgan said she did a 3 by 3, and I thought about it, and it would make sense because if I just have a 3 by 3 of all bricks, I could then mold each 3 by 3 the way I want, depending on if they meet the condition or not. So so it ended up making sense for me because you can like walk through everything, and each of this are like each individual room, and the sides are the edges. So that is what allowed me to visualize how cross-color is supposed to work on a graph and actually implement it. So to begin my presentation, these are my graph classes, but they're not really the big they're not really a big deal. So here this is I ended up not needing this function, remove duplicates, because it ended up doing that for me anyway when I was doing the union. So I just commented that out. So this is my union for my and this is my find set. For my ordering in ascending order, I use the bubble sort algorithm, which was from way back when I just decided to use it because I remembered. And this is my main class. Wait, before I go to my main class, this is my singleton class, where I used to build my strings. So here I decided to use the grass and the tree. Yeah, this is the tree and this is the grass, and this is my footer. I ended up making things simpler because I feel like I was running out of time. Alright, and now this is my main class. Here I initialize my vertices, then I populate them, and each of them has a label. So because they have a label, it allows me, when I was doing my Craskell and other things, I could just specify I could just use the label integers to see if they were equal to each other. Alright, this is actually redundant, but I did it because I was trying to debug my code. And now for here I pass in my graph, and I turn my graph into a 2-dimensional array because it would let me visualize what I was doing. And here I added the vertices. Before, I just had every every vertex having an edge to other vertex, which ended up making no sense, and that's what got me stuck. So I had to rewatch the notes or the lectures, and I realized that each vertices could only connect to the adjacent ones. So I wrote this to do that, and that propelled me forward. Now this is my main method that the class asks for. And here my crosscall class, and I call my crosscall minimum spanning tree graph, and I pass in the graph that I already populated. I already added the edges and the vertices here, and I this is the first print I do here. Then after my minimum spanning tree returns a tree, I print it out here, and then I call, this is like what actually builds my my map. So I call it better graph printer because I was just trying to like do things. But here what I did was, I created the map to stand it out first, and then when I saw that it was accurate, I added my map builder here. So here it builds, so if there's a star, it builds a brick. If there's an open space, it builds a tile, which means I named it build tile, but it basically just builds a grass in place of the open space here. And here, if there's a star, it builds a brick. So that's how I do it for all of them. It's just a lot of if-else statements. So I check if the edge can move, if this tree. So I check each through this tree, and I see if, if this 4 is connected to this 5, and if this 5 is to the right, it opens up the right side. So that's what I do. So yeah, so here I check for right side or left side. So when A is 1, it means that I'm on the top. So I only check for tops. So when A is 2, I have to check right and left. So first I check. This reminded me of I can't even remember what it, anyway. So anyway, I checked and for left and right. If it's left and right, then I check. If none of these are true, I just build its brick, tile, brick. So this space is referring to the room itself, the vertex itself, and the top, and the other ones are referring, these sides are referring to its edges. So this space is referring to where the player can actually be. And here I check right, I check left, and yeah, I just, here I just printed out to format it, and then after that I call my map builder, and I build the footer of it, and yeah, these are just for testing. These functions are just for me when I was testing my code, and here is where I create and I override my map. So if you wanted to test out the code here, you would specify the location of where the map.txml map.xml is. Alright, so I'm gonna run it. I'm gonna just pull up. So I'm gonna pull up my just gonna pull this up. So oh, give me a second. Alright, so this is the location for my of my class, but anyway, this is what I'm going to be changing. I'm sorry, I don't understand. Alright, there we go, here it is. So once I run this program, it's going to, when I click back here, it's going to ask me to refresh. And then I'm going to run it a couple of times to see. So here, I run it, program ended. I go back and I click here, asks me to refresh, I refresh. But anyway, I go here and I run my program, and so here everything is actually traversable. Traversable. Yep. It's actually, so I can get to everywhere. So anyway, I'll run it again so you can see it actually creates things. I'll run this again now, and run it back. As you can see, the map is different again. I'll do it again. Yep, you can see the map is different. Each time it's traversable. So yeah, I had a lot of fun in this class, and I thanks a lot for the help, and I've learned a lot. So thank you.